Have you ever really thought about the humble razor blade? It's something most of us use without a second thought, a small object that quietly plays a big role in our daily routines. But if you pause for a moment, you'll realize there's a hidden world behind that familiar edge, one filled with innovation, science, and meticulous craftsmanship. It's a tiny sliver of metal we use daily, expecting flawless performance. We trust it to glide smoothly across our skin, delivering a close shave without a nick or scratch. But how does such a simple-looking tool achieve such precision day after day? Behind that sharp edge is a story of engineering and precision. Each blade is the result of years of research, countless prototypes, and the relentless pursuit of perfection. Engineers and technicians work together, blending traditional craftsmanship with cutting-edge technology to create something truly remarkable. The process transforms a soft, flexible ribbon of steel into a tool sharp enough to split a hair. This transformation is nothing short of extraordinary, involving a series of carefully controlled steps that push the limits of material science. Most imagined blades are simply stamped out, but the reality is far more complex. Each blade undergoes multiple stages: cutting, hardening, grinding, and coating, each one essential to achieving the perfect balance of sharpness and durability. It's a dance of metallurgy and mechanics, with tolerances measured in microns. Even the slightest deviation can mean the difference between a smooth shave and a painful one. Robotics and human expertise work side by side, ensuring every blade meets exacting standards. The journey begins with a specially formulated stainless steel strip, astonishingly thin, about the thickness of paper. This steel is chosen for its unique combination of strength, flexibility, and resistance to corrosion, making it ideal for the demands of shaving. At this stage, the steel is soft and pliable, easy to bend, which is crucial for shaping. Skilled workers and precise machines mold it into the perfect form, preparing it for the rigorous processes that follow. From this unassuming roll, millions of razor blades are born. Each one is destined to become a trusted tool in someone's daily life, a testament to the power of human ingenuity and industrial mastery. So next time you pick up a razor, remember, you're holding the result of a remarkable journey. It's more than just a blade, it's a marvel of science, engineering, and dedication, all packed into a tool you can hold between your fingers. Let's see how that journey begins, and discover the fascinating process that turns raw steel into the everyday miracle we so often take for granted. The first step is all about brute force. The soft steel strip is fed into a massive punching machine, stamping out the basic blade shapes, called blanks. These blanks, still soft, are connected in a long strip, with slots and holes punched for razor handles. At this point, they're too soft to shave, form, not function. The strips are coiled onto spools, ready for the next phase: heat treatment. Before that, the brand name is printed and instantly cured with gas flames. Now, with their identity set, the blanks are ready for the real transformation. Next up, fire and ice. The journey gets intense. Now comes the heart of the process: heat treatment. This is where raw steel is transformed, not just in appearance but in its very nature. The journey ahead will push the metal to its limits, forging strength and resilience through a series of intense and carefully controlled steps. The process begins as the steel blanks are unrolled and fed into a massive furnace, where temperatures soar to over 2,000 degrees Fahrenheit. Inside, the metal glows a brilliant orange, its structure shifting as it absorbs the heat. This stage is crucial. It's where the steel's molecules realign, setting the stage for the properties that will define the final blade. After just 30 seconds in this inferno, the steel is red hot and ready for the next dramatic step. It's plunged into a cold water bath, a process known as quenching. The sudden drop in temperature locks in the hardness as steam billows and the metal hisses. This rapid cooling is what gives the steel its initial strength, but it also makes it brittle, like glass. To overcome this brittleness, the steel is sent into a deep cooling chamber, where temperatures plummet to -58 degrees Fahrenheit. Here, the metal is exposed to a cryogenic environment, sometimes even using liquid nitrogen, ensuring that every last trace of internal stress is relieved. This cryogenic step is more than just a freeze. It toughens the steel at a molecular level, making it more durable and less likely to crack under pressure. The result is a blade blank that's not only hard but also incredibly tough. But the process isn't finished yet. The steel is gently reheated in a tempering oven, a step that relieves internal stresses and reduces brittleness. This careful reheating ensures the blade will be strong but not so hard that it becomes fragile. The result is a blade blank that's perfectly balanced, hard enough to hold a sharp edge, yet tough enough to withstand daily use. It's now ready for the next stage, sharpening. This journey from fire to ice, from blazing heat to freezing cold, is what gives the blade its backbone. Each stage is essential, each temperature shift carefully calculated to create the perfect steel. Only now, after enduring this trial by fire and ice, is the steel strong enough to hold an ultra-sharp edge, one that will glide effortlessly through even the toughest materials. The transformation is nothing short of dramatic. In just a matter of minutes, soft, pliable steel is turned into a hardened tool, ready for precision work. Next, it's time to get sharp. The blade blank, now tough and resilient, moves on to the sharpening stage, where its true potential will be revealed. The art of sharpening awaits, a delicate balance of skill and technology, where the edge is honed to perfection. Let's see how a simple blank, forged by fire and ice, is transformed into a blade of remarkable sharpness and strength. Now, the hardened blanks are ready for their edge. The strip passes through a high-tech grinding machine with 3 abrasive stations. Each stage refines the edge, creating a perfect V-shape, microscopically precise. Computers control every detail for consistency. After grinding, the edges are polished with spinning wheels, removing microscopic burrs. The result? An edge 10 times thinner than a human hair. Once sharpened and polished, a knife slices the strip, separating the individual blades. For the first time, they're single, razor-sharp blades. Nearly finished, but a few crucial steps remain. Let's see how they're perfected and protected. A sharp blade needs protection to stay sharp. But what exactly keeps a razor blade performing at its best, shave after shave? The answer lies in a series of advanced coatings, each one playing a vital role in the blade's performance and longevity. First, every single blade is meticulously inspected under bright fluorescent light. This step is crucial. If there's even the slightest imperfection, the blade is immediately rejected. Only the most flawless blades move forward, ensuring that only the best make it to the next stage. The selected blades are then thoroughly washed and dried. This process removes any microscopic debris or oils left from manufacturing, creating a perfectly clean surface. A spotless blade is essential for the coatings to bond properly and perform as intended. Inside a high-tech vacuum chamber, a thin ceramic layer is sputtered onto the blade's edge. This ceramic coating dramatically increases hardness and resistance to wear, making the blade much more durable and able to maintain its sharpness through many uses. Next, a non-stick polymer is carefully sprayed onto the blade. This ultra-smooth layer reduces friction, allowing the blade to glide effortlessly across your skin. It's this coating that helps prevent irritation and ensures a comfortable, smooth shave every time. The coated blades are then placed in an industrial oven, where they're baked at precise temperatures. This curing process bonds the coatings permanently to the metal, locking in their protective properties and ensuring they won't wear off easily. The result is a multi-layered edge, razor-sharp, incredibly durable, and exceptionally smooth. Each layer works together to deliver a blade that's built to last and perform. Without these advanced coatings, even the sharpest blade would quickly become dull, causing it to drag and pull uncomfortably during a shave. The difference is clear when you compare a coated blade to one without protection. Every detail in this process matters. From the initial inspection to the final layer, each step is designed for maximum comfort, safety, and longevity. It's precision engineering at its finest. Now, the finished blades undergo one last round of rigorous testing and inspection before being carefully packaged. Only the best make it to the shelves, because when it comes to your shave, quality is everything. Next, let's take a closer look at how these blades are checked for perfection and protected for your safety. Even now, the blades face strict tests. Random blades are pulled for destructive testing, measuring sharpness and strength. Machines test the force needed to cut through standardized material. If a batch fails, the process is adjusted before any blade reaches customers. After passing, blades are submerged in oil for extra corrosion protection. Each blade is then wrapped in wax paper, preserving sharpness and ensuring safety. The wax paper reinforces the oil's protection and prevents accidental cuts. Simple, effective, and time-tested. Only now are the blades ready for packaging. From raw steel to finished product, every step is about quality. The journey is almost complete. And there you have it. The journey from soft steel to precision razor blade. It's a story of fire, ice, and microscopic engineering. Next time you load a blade, remember the science and skill behind it. That edge, thinner than a hair, is the result of countless steps and checks. The average blade lasts about 6 shaves, but the work behind it is immense. Over a lifetime, we spend months relying on these tiny marvels. The humble razor blade is a testament to human ingenuity. Even the simplest tools have extraordinary stories. So, when you enjoy a smooth shave, you'll know the journey that blade took. Every shave is the result of a remarkable process.